Hi, everyone. My name is Florent Jeté. I'm head of strategy and business development at Storenergy. And I have the privilege to be the chairman, to be chairing this roundtable. So today we have been discussing already quite a lot HyPSTER results. And I think you understand that at Storenergy we are already proud of this achievement, of this result. But I'm sure that you are aware that getting there is already really challenging, and for good reasons. But you're also aware that the journey that we have to go through with all our storage colleagues are not over yet. So during this roundtable, with my colleagues from companies which are on the same journey, we would like to discuss why these challenges need to be overcome so that we can move on. And also we'll discuss what are the next steps for storage to bring this emerging market a reality. So to start, we are going to take a quick run of the table so that our guests can introduce themselves, present the projects they are working on, and share their thoughts on what their learning are on their projects. So maybe Eddie, we will miss you on the stage, but really a great thank you for participating remotely and accepting this solution. We'll start with you, if you will. So Eddie, can you quickly introduce yourself and tell us a few words about the energy stock project from your company, Gazuni? I think people in the room would love to hear from you. What are the learnings that you have so far from your projects?
Yeah, thank you for the introduction, and I'm really happy that I can join via the internet. Unfortunately, not able to join in person, but well, happy to share our findings. So first of all, Gazuni, introduction to Gazuni. We are a European energy infrastructure company involved in many new energy projects. I don't know if you see my presentation on the screen.
For now, we see you, which is already great things.
Yeah, great. I can share my presentation.
Yeah, maybe the easiest way is for you to share the screen.
Sure.
And you can move around your slide yourself. Okay.
Hope you can see my screen.
Yeah, we can see your screen.
Great.
Maybe you can enlarge it, but otherwise we would work like that.
I could try, but I won't spend too much time in it. I have enlarged it on my screen, but most probably...
Okay, I think we can see them. So yeah,
great.
We can go like that.
Yeah, so Gazuni is a European energy infrastructure company. And we have an ambition to be a driver in the hydrogen market in the Netherlands and in Germany. And that's based on an open access and a non-discriminatory process, which means we build either fully owned or in partnerships infrastructure, and we allow everybody to make a contract with us and use the infrastructure. We have 4 strategic themes, being transport of hydrogen, storage of hydrogen, import, and the offshore network. Well, nice words. What does it mean in projects? This is a schematic of the Netherlands and the part of Germany, and I've plotted all the projects that we are working on, which ranges from CCS to heat transport networks, to a hydrogen transport network in the Netherlands, but also in Germany, and a offshore transport network for hydrogen. And then the topic of the day, also hydrogen storage projects, and I've circled them with red circles. The HyStock project in the Netherlands.
Eddie, yeah? Maybe you want to switch to the next slide?
Doesn't it function?
Yeah. Yeah, here we go. Thank you.
Yeah, great. We'll do it like this. So this is a map, as I mentioned, and red circled is the hydrogen storage projects that we work on. The HyPSTER project in the Netherlands. H2Cast is a pilot project in Edsel, and we work on a project which we have called Speicher, which is a working name, and that's also a hydrogen project similar to HyStock, but then situated in Germany. And then very brief, what do all these projects mean? Well, we operate a UGS in the Netherlands with caverns. That's a multi-cyclic, fast-acting installation. And in 2017, we realized hydrogen would become important, and we have installed a electrolyzer of 1 megawatt, which is still operational, fed by our solar panels. And that was our first HyStock project. Then in 2021, we started with a demonstration project called A8 demonstration project, where we had a small cavern, which we filled with hydrogen, where we tested materials, we tested the integrity. So quite similar to what HyPSTER has done in a way, but then on a smaller scale with less hydrogen, but with positive results. For us, that was a basis to continue with our HyStock project, which is a full-scale hydrogen storage facility. It should be commercial operational in 2029 with 1 terawatt hour of storage capacity and 80 tons per hour send in, send out capacity. So really full scale. And it will be it's not immediately 80 tons, but we start with 20 and then stepwise go bigger. The H2Cast project, pilot project in Edsel, where we test multi-cyclicity of the caverns, and we build a surface facility to experience or to test the most efficient way of purifying hydrogen to get to the required quality. And like mentioned, the Speicher project, which should be operational somewhere in 2032, which is comparable to the HyStock project, but then located in Germany.
Okay, thank you, Eddie.
Sure.
So now turning to you, Andre, can you quickly introduce yourself and tell us a bit about the extension of Grenoble site to welcome the first H2 storage on your site? We know it's not a demonstrator or a pilot. We'll love to hear what you have learned so far on this project.
Yeah, thank you. Hello, everybody. My name is Andre Tembrock. I work at RWE Gas Storage nearly since 20 years in the region of gas projects, storage-related topics, and at the moment I'm responsible. At the moment I'm responsible for the operation of all gas storage in Germany. We operate, and within our hydrogen storage project, I'm supporting the core team, especially in permitting questions and also in safety-related topics. And I'll try to explain to you what we are doing in the project. Maybe we come to the next slide. Yes, right. We are in an HyPSTER project. You can see on the left corner that RWE is installing a lot of hydroelectrolysis capacity in an existing power plant in Lingen. And the idea of this program is to build up the whole value chain. The production is at Lingen because all the electric circumstances are there. Now the grid connection is there, and now there's a lot of space, and they try to build up the electrolyzers to produce green hydrogen out of wind energy, and in combination with several TSOs, gas transport operators who convert existing gas pipelines to the first hydrogen network in North Rhine-Westphalia in Lower Saxonia. They will give us the possibility to transport the hydrogen to consumers, especially in the Ruhrgebiet. Now there are a lot of steel producing consumers and petrochemical companies who at the moment produce hydrogen from hydrocarbons, and in the future they will replace them with green hydrogen. And to make this system run, now they need a source of flexibility. And there we come into the game, and we try to build the first storage in Germany that is really used for commercial background. And we will support them with the flexibility they need to produce the whole day, and also when the wind is not running and blowing. And just some key figures that we heard in the morning. Something about capacity is about 3 tons. Our projects that we will store 3.5 megatons. It's a bit bigger, and we will build up on that what was learned in the already done in existing research projects, and we try to build a real facility. And on the next slide, you can see some impressions what we are doing now. Now we started in the beginning of this year to bury a lot of concrete, and now we are in the phase that we are building real houses. Now we're digging pipelines, and on the left corner you see a 4 weeks old picture of the building site. Now you can see the compressor holes in the right side, and on the left, on the right picture, you can see the first pipelines. Now, at the moment, during this weekend, we are drilling 500 meters below a forest to install the first pipeline to the cavern. And one picture below, now you can see one of the first compressors we ordered in the factory acceptance test. Now the base frame from this compressor has been delivered last week to site and is sitting on the basement up to now. And in the next weeks, we try to install the roof so that the installation can be finished in 2026. Then we try to start with the first commissioning activities, and also with the first fill of one of the 2 caverns that will be connected to that site. And at the moment, we expect that we can use the first cavern in 2027 for commercial operation. And then I was asked to share my key learnings. Shall we do that now or later?
Yeah, you can share you first. Yeah.
Yes.
Especially on the project.
Regarding our project, what we really recognized was that there is a lack of experience on all sides, especially on our side. Now, we've never built a hydrogen storage up to now, and we have seen many challenges that we have to keep on. And we already found now unforeseen topics, now especially on venting and flaring is a big topic on the surface facilities, and also the purification unit that we have to use. Now, compressors are not the problem. Now, you can order them in the catalog, but everything else is really new because of the high pressures in the cavern and also the big volumes we are talking about. And we are building there a small storage, but also this small storage is very, very big. Now, at the end, we are talking about 3 compressors and 3 withdrawal trains that will be installed now. And that's quite interesting. What we also learned is that we had a lot of delays because of the funding process. Now we have to spend a lot of money in advance. Now nobody told us, no, you get anything of that back. But we did it on our own, and now we have some funding and it works. Some positive aspects also. We had a very, very good contribution from the authority side. The permitting process went through very, very fast and clear. That was very nice. And what we also recognize is that what we do today here also is a very good contribution and a good exchange between the operators and people who are forcing these projects.
All right. Thank you very much, André. Matthias, can you introduce yourself and tell us a bit about EU H2 stars from your company RAG Austria, and also please share your first learning from this project.
Thank you, Florent, and thank you for inviting us. It's not common as a porous reservoir storage operator to discuss with cavern storage operators together in a workshop, so we appreciate the invitation. Yeah, on the first slide, or about myself, my name is Matthias Kreimel. I'm with the Green Gas Technology Department at RAG. Our department is in charge of all the green hydrogen R&D activities. So we have already several projects finished, which will be on the next slide. But first of all, I would like to give you a brief overview about our operations. So we're one of the biggest storage operators of Europe, Austria's biggest. All of our operations are in the area to the northeast or north of Salzburg in Austria, as you can see. There are two locations that are of particular interest for my department. That would be the two yellow-orange-ish circles, Pilsbach and Rubensdorf. Pilsbach was the first R&D site with regards to hydrogen that we developed more than a decade ago. Rubensdorf is now the second one. That is the first hydrogen storage demonstrator for 100% hydrogen in depleted porous reservoirs. The remaining storage sites that you can see, the blue-white circles and the green-blue or green-white circles, those are our commercial natural gas storages. The storages for natural gas, they have an overall capacity of 6.3 billion cubic meters of natural gas, which translate into roughly 72 terawatt hours of energy stored, with an injection and withdrawal capacity of around 25 gigawatts. We can provide this power for more than 3 months. So there you can see porous reservoir is a very nicely complementary storage to a cavern. Cavern can deliver power, porous reservoirs can deliver capacity. So they really can complement each other very nicely in an energy system. If you could switch to the next slide, please. I brought a little bit of an overview of all our R&D activities that we have carried out already. So on the top, you can see the project Underground Sun Storage that took place more than a decade ago and was developed at the Pilsbach site. That was our first pilot, where we had an admixture of hydrogen up to 10% in natural gas injected in a depleted porous reservoir. That project was accompanied by a lot of research. So with regards to material testing, with regards to cement, steel grades, polymer grades, also the effects of hydrogen on cap rock and reservoir rock. All these tests have been actually very successful. The Pilsbach site is still in operation today. So the left path that you can see there were the follow-up projects that were done in Pilsbach. The first project actually delivered two main results. The first result was the detection of geomethanation, so the microbiology that transforms or converts hydrogen and carbon dioxide into methane. Well, throughout the follow-up projects, we tried to understand the process better and speed up the process significantly. With the last project, we also have taken the CO2 source into account. So in this project, we can fully demonstrate a carbon cycle. So we take the CO2 from biogas or from an industrial plant, inject it with hydrogen, produce methane, deliver methane to the industry, so the carbon is really going in a circle rather than being released into the atmosphere. The second important result of the first project was the material testing part. So we've carried out material tests, 100% hydrogen at 100 bar partial pressure hydrogen, which gave the necessary confidence with regards to materials to go for the Underground Sun Storage 2030 project, which is the first, demonstrator for hydrogen in a depleted reservoir at 100%. This project is now coming to an end, and the follow-up project was mentioned this morning already by Mirella. That's the EU H2 Stars project. That's the abbreviation for European Underground Hydrogen Storage Reference System. In this project, we are together with various European storage operators, research organizations to, pave the way for the future of European underground hydrogen storage. I'm not the only one present today of this project. So from our Hungarian partner, there is Nora in the room. And from what I've seen, also the storage companies Shell and Trinity are present online, as well as TNO, a research organization that is working with us on that project. If you could go to the next slide, please. I brought a brief overview of what has been going on in Rubenstorf so far. So under the Austrian project, we have basically done an injection of natural gas as a cushion gas at first. That's the red curve that you can see. The black curve would basically be the instruction, followed by about 600,000 cubic meters of hydrogen injection, of which about 100,000 were working gas. That working gas was produced. Result was very favorable. Actually, no H2S, hardly any mixture with hydrocarbons, but still it's only a part of the working gas volume. So the full picture we will see once we've circulated that fully. And now currently we're also injecting hydrogen. Unfortunately, we also have to rely on tube trailers since our electrolysis is not very satisfactory in its operation. Still, we're confident that 50% of the working gas volume will be in place by the end of the year. And afterwards, we are intending to produce that. Yep. Can I have two more sentences? Okay, thanks. With regards to what's coming up in the future, that's the EU H2 Stars project. So that project includes at our side 4 more cycles with the demonstrator. It also includes scale-up studies. So the demonstrator has, of course, a limited working gas volume capacity. So we're looking into the basic engineering of commercial settings of storages. We're also looking at the integration of the storages, so the integration into an energy system and, well, public acceptance and stakeholder management. But we're also working on standardization and recommendations. So together with the other storage operators, we aim to develop standards and recommendations for storage side.
An important topic indeed. Thank you, Matthias. So Frank, can you introduce yourself? And since we know a bit HyPSTER now, maybe you can jump this part of the question.
Thank you. Then we will save time. I'm Frank Josek. I'm working with Storengy UK. We are in the northwest of England, next to Manchester, a very nice place where we have a 5 terawatt-hour storage with 20 caverns. And there is an opportunity next door to build a brother or a sister for the storage. We don't know yet the gender, but it could be something like 1.3 terawatt-hour of hydrogen. That means that to do that, we will need to drill and to develop something like 19 caverns. Then when I'm hearing news or conclusion from pilots, from projects, for me, it's really interesting because it helps to make the case for the stakeholders. It can be for some company, internal stakeholders, because you may need to convince the high-level management that hydrogen is doable. And for us, it's not the case, luckily, but all the things that we are learning right now are really useful to convince the UK government, because as you may know, the UK is not part of the EU. That means that we don't have the same kind of incentives, the same kind of policy. And then for them to really believe in hydrogen, we need to be sure that they have in mind that storage is doable, technologies are ready, and we know how to implement them. Because you can be with all the best technologies. If you don't know how really to put them into motion, you will be stuck. Then this is really useful for us at Storengy UK to look at what has been done by HyPSTER, your pilot 2, your project. And I think that we need to be somehow very careful not to repeat some conclusions and to be sure that we are moving forward and that we will be able at the end to have an holistic approach and an holistic argument to convince the stakeholders.
Thank you, Frank. I really like your remark on coordination, and I think we will discuss that a bit later. for the moment, I propose to discuss a bit further the benefits of these projects. These projects are gathering a lot of players and stakeholders. So I would like to ask you how partners, our suppliers and stakeholders are benefiting from these projects. And maybe, Eddie, if I can ask you the question first.
Yeah, sure.
We can see you.
Sure.
We can't hear you.
Oh, you can't. That's unfortunate.
Just a second. We're trying to fix that.
Hopefully it works now.
Great. Thank you.
Yeah. So yes, indeed. So I think we were as Gasunie a early mover when we prepared our pilot project end 2020. And we had first discussions with suppliers of materials, in particular from well materials. And they were rather skeptic, and actually they did not have and still do not have a brochure with hydrogen ready equipment. But it has changed, and now with all the pilots and all the initiatives of hydrogen storage, suppliers have become interested in doing investments and taking action in the pilots and join the action pilots to come up with materials that can be used. So that's a good thing moving forward. And the other thing, yeah, we have to convince the authorities, like mentioned by Frank. We have to convince the people living around the storage place that we can do things properly and safe. So the confidence in the industry, in the hydrogen storage industry, is of vital importance. And I think we can only achieve that with collaborating and sharing information and make sure that that we do get the confidence and do not misuse this confidence. So that's really important, I believe.
Thank you. Frank, do you want to share your thoughts on this subject as well?
Yes, thank you. In the UK, the government is putting together hydrogen business model for storage, transportation, production. And the main question for them is the technology readiness level, the TRL. What they mean by that is not only are you able to demonstrate that the TRL is at 7 or 8 or 9 or whatever. They are really asking, are you really able to use this technology, to put it together and to use it? Somehow they know the story of electrolyzers, that the technology is known and ready, but people are struggling to put electrolyzers really at work and to produce green hydrogen at scale, etc. Then they are asking really to demonstrate the TRL. And when they ask that, they don't only ask that for compressors, you know, for the one that you are installing, but they are asking that for the underground too. They are asking us, hey guys, when you will do multi-cycling with your caverns, what will be the impact? Are you sure that the rock cavern will be tight enough to keep the molecule? Are you sure that nothing will happen, etc., etc.? Then I see Grégoire here saying to me that everything is fine. We will be able to have a meeting tomorrow morning. Thank you, Grégoire. But when I say that, it can be seen as, oh yeah, it's not a big deal. But in fact, we are with this kind of questions. These kind of questions, when you struggle to say, that's not a real problem, but it is not the answer that you need to put on the table. You need to come with, we have tried. Grégoire is very confident and he will demonstrate with the figures. Matthias has done some crazy things. He will explain too. Then we are not only coming with academic results, with research that has been done in labs, but we are coming with proof and experience. And that's really key. Just for a small part of all our discussion with the UK government, at some point, the government was saying to us, oh, storage will be ready at the end of the 30s in 2038, maybe. We were like, what? Why are you saying that? Oh, because we don't think that you know how to do that, guys. You are not ready yet. And for us, it was like, no, this is not the case. We know how to build, we know how to operate, and we know with the pilot that are running in Europe how to do it. Then you need to come with argument. You need to come with experience. That's really one of the key. After that, if I may add a very last point, when you are with a project like the ones that we want to develop, you have a lot of uncertainties. That's for sure. For example, you are talking about the bacteria. We don't know what will be produced, but with all the experience that we will build with the pilot, we will reduce those uncertainties. And I think that's really one of the key for us.
Thank you, Frank. Very optimistic. That's great. So now looking at the future. So I would like to hear from you what you think are the next critical steps that the storage operators need to take in order to be successful in the development of their UHS assets. So since Frank mentioned it, I think that would be interesting also to question you on how can players coordinate themselves to be faster and also to be sober in terms of resources invested. And maybe on that, Matthias, if you can take it.
The question on what would be the next steps for us. All right, I'll split this answer in two parts. So first of all, I would talk about the overall situation in Austria. So that's not really influenceable by us. And then I'll come back to our perspective as an operator. So in Austria, we're still missing a lot of regulation with that regard. So typically a storage, you run under the Mining and Resource Act. And that law in Austria doesn't incorporate hydrogen. So the term storage is there only applicable for hydrocarbons. Unfortunately, hydrogen is no hydrocarbon. So our demonstrator is not a storage site, it's a hydrogen warehouse. If we talk to our authority. So that's a law that needs to be adapted. We're also lacking a regulation for the infrastructure at the moment. So, I mean, it's nice to have a storage, but if you cannot connect the storage to anywhere, to your customer, to your producer, then it's going to be an empty or lonely storage, so to say. So there are some challenges on the regulatory side, on the market side that need to be tackled. From our side as operator, we actually feel after this decade of research actually very confident. So a couple of months ago, I was approached by a researcher and he was asking me, Matthias, if I give RAG €1 billion, would you be able to build a hydrogen storage? He was a bit surprised because the answer was yes. The answer was such a surprise to him that he also approached my reservoir engineer colleague who was with me on that day. He asked him the same question and he also got yes to hear. So he was a bit confused because he expected a different answer. But concluding from a technical perspective, from the material side, from the integrity of the storage complex, well, reservoir, caprock, we're actually rather confident that we can handle all the risks that are associated to it.
Thank you, very clear answer. And Andre, do you want to add something?
Yes, maybe some points that doesn't work. Yes, works. Now, some points to add. We heard the circumstances must be clear, especially to build a surface facility, and therefore you need clear parameters. Oh, no, it's too loud. Okay, now the parameters must be clear. Now, to get a permit for a storage in Germany, now therefore you need a grid connection. At the moment, the core grid now is decided to will be built, but the last kilometers are missing now, and the storage operator has to build it on their own. And we don't know at the moment what the pressures will be, what kind of parameters are necessary to design the facility itself. And these points must be clear, especially the quality discussion at the moment in Europe is a big point. Without knowing which quality must come out of the storage, you cannot design the facility. And without knowing that, no project will start. And on the other hand, for us at RWE, it's quite clear we will not build another storage without financial support, state aid, something like that. At the moment, it's not beneficial for us. We did the first step, now we try to bring it on the road and to learn from that, but we would not do it a second time. And what also is in our eyes one of the drivers at the moment, there are not enough projects really running. A lot of FIDs are not taken. Everyone is talking about to build a storage, but it must also be done to gain experience and to learn from that. And that would be one of the best steps we can do together.
Thank you. So now I propose that we take a step back and instead of focusing on storage operators, maybe we can look at our ecosystem and wonder what we can do as storage operators to support them, to support the development. On this question, Frank, do you have some thought to share with us?
Yes, thank you. In the Northwest, we have then players that are producers, people that are working on the transmission, us working on the project to store hydrogen. But that's fine, that's great. But we are missing the final part of the project. The final part of the project is the customer. Right now, when we were talking with the government, we were assuming a customer like a customer, you know, the one that you just talk about, but you don't know really what the needs are, what they want, what they dream about. And then the producer, the transmission, and the storage put together a roadshow. And then we went and talked to customers. We had, in fact, a lot of feedback, a lot of very, very interesting feedback. Some people were with a different kind of background. That means that some of them were asking very tricky questions to the transmission. Some of them were very interested by, oh, is there a storage part of the story? Because I'm a picker and I would like to produce with hydrogen as a blend or 100%. Let's say in 2035, I would like to do that. Okay. Then they were coming with a lot of interesting questions. And all those questions, in fact, are helping us to build a case to give feedback to the government. Because now we are not talking about a potential customer. We are able to give names. We are able to say, here, there is this company at this location building this kind of project. You know them, they have talked to you, etc. Then they want to be sure that a storage is part of the story. They want to be sure that they will receive hydrogen with the transmission line by this date. Then with this kind of roadshow, we learn a lot, and we are able to really build a substantial and robust business case when we talk to the stakeholders, especially the governments.
Thank you. André, do you want to add something?
Yeah, maybe concrete actions that have to be taken now. In our eyes, is to proceed with a good exchange. It's not necessary that failures have to be done more than one time. And would also be very helpful for the whole project is to align on standards. What has to be built, how it has to be done, and at the end, you can buy it. So that would be my input.
Okay, thank you. So I see that we have a bit more time, and before we lead the floor to questions, if any, do you want to share any final thoughts on this project and on project development?
I have one point. When we are talking about execution of the project, we think about EPC, PCM, or whatever. And I think that for a lot of you, it resonates like, oh yes, that's difficult. And we don't know really what will be the appetite. We have seen in recent years some acquisition, merging, etc. on the EPC market. That means that tomorrow it can be difficult to develop our project. We may be in competition with some companies. And for me, it's not a concern, but this is really a strong point of attention. Then the EPC and the EPCM market need to be understood a little bit more for us to be able to really execute.
Thank you. Eddie, do you want to say something?
Yeah, I would like to add something to what Andre just mentioned. I think it's really of key importance to share experience and make sure indeed that we do not make mistakes twice, and try to step forward, and instead of staying at the same place and repeating ourselves, we have to move forward and do the job. So it's great that RWA is so far already with their project, but I think we need more of them to really make it happen.
Thank you. So thank you very much. I think that all of us is here measures the effort and the engagement that we had to go so far. We also measure what still needs to be done. And I think we can all share the confidence that you have proven on the stage today. So thank you very much. Now it's time for questions. So please, in the room, if any, and online, of course, we can watch your question as well. Here is one.
Yeah, thank you, Maurice Schlichtenmeier from ESK. You're all storage operators. So who do you think will be in future be your customers? Who will be buying the storage capacity, and would it be the storage capacity that you will sell to your customers, or will it be power? Or will the basis for the pricing rather be the stored hydrogen, or what's your expectation about that?
If I may, I will start. We can even sell a sort of flow rate for a picker, for example. It depends. In the UK, the government I was mentioning is building an hydrogen storage business model. That means that they are defining for the first 15 years how the market will run, how things will happen. Then, in fact, they are doing a procurement, or they are planning to do a procurement, a public procurement. They mean that they will be the one buying the storage capacity, and we will need to be able to deliver, and they will give us some guidelines. This is really the idea, okay? We are not into the details right now. They will give us some guidelines to say, we would like you to be sure that you will allow 5 or 6 pickers to develop in the area with this kind of power, because we trust that the hydrogen need to be used for electricity production, etc., etc. Then somehow, we are not really talking about customers during the 10, 15 first years. We are more talking about the egg and chicken that someone was talking about in the other panel. Then in the UK, they have decided no egg, no chicken. We go directly to the cow, and with that, we build an ecosystem in this field, in this area.
Well, actually, I mustn't know who our customers are, but my colleague from our gas marketing department is here, so I could maybe forward that to you, Georg. But I think the customers for hydrogen would be rather the same than they are for natural gas. So we have, well, government, traders, industry, utilities. That's Georg, if you want to add on that, please.
Yeah, maybe I take the chance. I think it's actually quite interesting when you listen to politicians who they target as customers. It's always the energy intense industry. So those who have like really big energy demand, they will be the hydrogen customers of the future. And then you look at the same time the very specifics of building up and ramping up a market where you really struggle to bring in the infrastructure and especially the demand and especially the supply of hydrogen for that. And when we talk in our region to potential customers, it's never the energy intense industry. It's always the industry which is actually more, they have a very specific interest. They want that. As I heard today in some presentation, they said like, we have customers who have an interest to use green hydrogen because for them, the product becomes more interesting then. This is a trigger for many industries, but they have not. When you have an industry which has like 70% of their costs is triggered by energy costs, it's very tricky to use green hydrogen for them. And I think that is playing a big role in who is that first, let's say like that first mover customer. I think in the future, when we talk in 15 years where we have cheaper available hydrogen, bigger import routes, I think it will be more narrow maybe in the customers and the usage of the storage. You will have trading, you will have a big industry, but I think this first industry and the first users of the green hydrogen or hydrogen in general, you will really need to question to whom it fits and who is able to pay for that premium.
Thank you for elaborating, Georg.
And maybe I can add one other thing out of our experience now. The project we are working in, all the customers are real industry customers. They don't use the hydrogen for burning or for producing electricity. They use it as a product. They substitute the hydrogen they produce in the past from hydrocarbons and use the green hydrogen as a real product. And what they want is, they don't need a storage. They want a full flexible product. And they ask for, deliver me the hydrogen that I need for my production the whole day, the whole year, whenever I like, and with everything that is necessary therefore. And they are not really interested in storage. They want the product itself.
Any other question in the room or online? All right. Well, thank you very much for participating to this roundtable. And I think we will be glad to see you again.
Thank you.
Thank you.